protocol. But obviously, if you don't, it is your responsibility. Okay, so let me start our lecture 1, IoT, and very important a chapter. Just like the last semester, we had access technologies were very important. Architecture standard were very important. This one is a very important chapter for this semester. The main chapter, actually, you have seen in the module map, it covers something like 5 weeks or so. Because when we talk about IoT systems, about sensor systems, I think at the start I've told you there are a number of technical things that we will have to study. Is not if it is only a matter of getting a few sensors connected to a microcontroller. This you require only 2 hours to complete to understand how to connect a sensor to a microcontroller. There's nothing to learn as such there. But however, there are a number of, for example, protocols that have been devised, have been proposed for sensor systems. And these are the protocols that we are going to discuss in this lecture. Recall from first semester, there was a point that a number of times I have discussed with you. Maybe if anyone recall can remind the class can remind me why. My question is, we have already addressed this question in first semester. I think some 5-6 times we have discussed this question. Why existing protocols, for example, since we talk about internet and eventually our IoT, our sensor system need to transmit over the internet. Eventually, I want my data to go on a cloud platform, for example. Why existing protocols cannot be used in IoT system? Why we are having to come up with other protocols, with new protocols for IoT system? Why we can't use our traditional, for example, what do we use on the internet? If we want to transmit over the internet, which protocol shoots do we use? Anyone from the class? Which protocol do we use over the internet, the normal internet?
TCP/IP.
Obviously, so it is TCP. It is TCP/IP. We use TCP/IP. I think we have discussed so many times why for sensor systems, for IoT application, these are not appropriate. Yes. I put the question to the class. Anyone? We have discussed these many times in my different lectures. Actually, this question was addressed.
Technologies for IoT system are not IP enabled.
They are not IP enabled. Yes, true. Other students, why they are not IP? Why we are not able to use this protocol? What are the characteristics of IoT systems, sensor system, that makes it difficult to use TCP/IP, for example, or other protocols that have been devised for your networking, general networking? What characteristic of IoT that makes it difficult? There are a number of characteristics of IoT systems, of sensor system, that are unique to sensor system, because of which we cannot use our traditional protocols. Yes?
Power consumption.
Okay, yes. So already we have one of your friend is saying power consumption. Yes, what happened is that those traditional protocols, they are greedy in terms of power. They use lots of power. Our IoT system, they are constrained in terms of power. So if we apply a protocol which is heavy, okay, so it's only a matter of heavyweight or lightweight. So most of the existing protocols, they are heavyweight. They consume lots of power, whereas IoT, we have a constraints of power. Yes, one already. I need at least 3.
Transmission ranges.
Transmission range. Okay, it can be considered, but even for normal networks, for traditional networks, we have short range communication, we have long range communication, and recall from my lecture of access technologies, even for a sensor system, we have short range communication like Zigbee, Z-Waves, and everything, or even BLE, Bluetooth Low Energy. And we have long distance like LoRaWAN and Sigfox. So I don't see really the point why, what is unique for sensor system. The communication range we have short, have long range. Yeah.
The relationship between maybe frequency over technologies, and data rates.
There is always this matter, but IoT do users even 2.4, that normal network, like your Wi-Fi is on 2.4. We have protocols on IoT that uses 2.4 gigahertz. So it's not really a matter of frequency. Yes, it's true that there's a relationship between frequency, data rate, and transmission range. That's true, but I don't think this impact whether we can apply it on IoT, on sensor systems or not. Yes, so we already have one. One of you have said power. Power, energy, IoT is low energy. Our traditional network, they can consume a lot more power. So this is one. I still need three asset in all. I still need two more. Yes. What is unique in IoT systems, in sensor system, that makes it difficult to use existing protocols like TCP/IP? There are so many things actually. It is processing capacities of those devices. We are talking about energy constrained devices, low processing capability devices. So this is another another one. And when we talk about sense system, very often it is machine to machine communication that require other set of logic for the communication to happen. So you have the bandwidth issue also for these for these technologies, and the unique characteristic. Recall from first semester, I have told you very often in most networks, the objective was what? Have higher bandwidth, more capacity. Because even when we talk about TCP/IP internet, we want more download speed, more upload speed, higher capacity. But whereas in IoT, recall after you, very often we don't need high capacity because I'm sending very small amount of data, but very frequently. This is another point now, where unique characteristic of IoT, of sensor system. First, we send very small amount of data. Those existing protocols, TCP/IP, they are heavyweight. They are made to carry large volume of data. Here we need to carry small volume of data. But first point is small volume of data. Second point is what? The transmission. What about the transmission? Anyone in the class? Small amount of data, but very frequently. You recall from first semester we have said this a number of times. Small amount of data, but very frequently. So and our existing protocols, even TCP/IP, are not in line with this. They are not devised to carry small amount of data that needs to be transmitted very frequently. When I say very frequently, it is in 1 second we may be transmitting it many times. So for all those reasons, we have just done a brainstorming here. For all those reasons, existing traditional protocols, TCP/IP and everything, are not suitable for IoT, for sensor system. This is why we have to come up with new protocols for sensor system. This is why you're having this very important chapter to know what are those protocols, because it is not even those routing, messaging, networking protocol that you have used in your traditional networks are no more valid for this for a sensor system for IoT. Okay, let's get started. Okay, so this one I have just explained to you. So it's network of physical objects. We're talking about devices, vehicles, and everything, and other items like electronic software sensors that enables these objects to collect and exchange data. And very often we are talking about a machine connecting with another machine, a sensor connecting with another sensor. This every one of those sensors and control points is generating data. So it is lot of small data. Often it is very informative and very private data as well. So there's an aspect of security that comes into play as well. So systems are needed to help those devices talk to each other. This is where the protocol is coming into play. So talk to each other, manage all that data, and enforce proper access control. This is a security part. So all these things need to be catered at the level of the protocol. So rationale for having why additional protocols for sensor system for IoT application. So a lot of internet traffic is generated, okay, and consumed by machines. So after you, it is very small amount of data, but when you take those frequent transmission and we take every second we are capturing sensor data, at the end of the day, it is a large volume that needs to be transmitted over frequently. So it is not at once you will send small amount of data, but when you are continuing to use the system, then you will see at the end of the day you are collecting large volume, because you don't have one sensor, you may have millions of sensors sending small amount of data. So the volume of data at the end, at the cloud system, for example, it can be enormous. Data sources and data sinks. Data sources are those that produce the data sensors. Data sinks are those that consume the data. Okay, for example, your cloud platform or machines. So machine-to-machine communication. We need to ensure that the data can be secure. So security is always a consideration, an issue, from the source to the sink. And very often the source, it is distributed in the environment, in the physical environment, where security become even more difficult. And we are using the wireless medium, so it is become more challenging. Okay, here is the slide we have just discussed. So one of the biggest challenges faced by architect developers while dealing with IoT project. So yes, it will be the case for you as well. When you will be implementing any IoT system, one of the important consideration, one of the important decision that you will have to take is which protocol will be more appropriate for my application, for my system. So this is always a difficult decision. Why? Because there's no one protocol. You know, most of the time, if you are developing a wireless system, you know by default it is Wi-Fi. So you don't even ask yourself the question which protocol you are going to use. Wireless, short distance, medium distance communication. So by default it is Wi-Fi. But this is not the case for IoT system. For IoT systems, excuse me, you don't have one protocol that have been proposed. We can say it can be used in all situations. So this is why we are having here in this module to study different protocols that can be used in different situations. Okay, so it says here, this stems from the fact that standardization in IoT protocol is virtually non-existent. There is no standard protocol, one protocol we can say that everyone can use. Maybe in the future we can have it, but right now we don't have it. So the root problem is a constrained environment. We have just discussed about this. Okay, a constrained environment of IoT characterized by low memory. We don't have large amount of memory. Low power. One of you mentioned about energy, about power. Low bandwidth. I've told you about bandwidth requirement, and high packet loss. Okay, for example, in TCP/IP. When there is a packet loss, there is retransmission, acknowledgement, and retransmission. This is not possible in IoT because there is a high probability of packet loss. By nature of the network, there is a high probability of packet loss. So this is why, again, our traditional protocols like TCP/IP. So combine these do not allow TCP/IP stack and web technologies to be used easily for IoT. I'm not saying we don't use it. I'm saying that it is not easy. It cannot be easily used. We need to do things about a number of consideration needs to be taken. Okay. So, however, to solve this challenge, there are hundreds of proprietary protocols. This is our problem. At the same time, it is a good thing that we have different possibilities, but at the same time, it is a disadvantage in the sense that we don't have one protocol. We have many protocols that have been proposed, and very often these are proprietary. You know what are proprietary protocol, not available for everyone to use. In IoT, so machine to machine and home automation space, there are different protocols. For example, Zigbee, Z-Wave that have been proposed. So though these protocols are supported by IIS, that is many companies, many vendors are supporting those protocols, they are not standardized like TCP, IP, HTTP, SMTP. These are standardized protocols. Anyone, anywhere can use those standard protocol to develop application. Whereas for IoT, we don't have our standard protocol. However, we have a set of open standardized set of protocols have started to emerge. Yeah, we are not like completely zero. We are starting to have, because we are very early in the history of IoT or sensor system. We have a number of protocols now that have started to emerge as standards. So most bodies such as IEEE, I've already introduced these bodies to you, IETF, W3C have standardized protocols such as 6 low wireless band. This was discussed in first semester. I recall we have discussed CoAP, Constraint Application Protocol. CoAP stands for Constraint Application Protocol. So we are starting to have standardization of those protocols for IoT. So in the long run, these protocols would emerge successfully, like the open standard web standards used by web today. So hopefully, these protocols can become standard and everyone will be using them. So in your case here, you're having to understand, to learn those different protocols, and because we don't know which one will become standard in the future. But the major one I will discuss with you in this chapter in the next few weeks. These are the major one that we are going to discuss. Yeah. Maybe since we are discussing, and in this lecture here for today, I'm just introducing to you the different types of protocols. And as from next week, we are going to discuss specific protocols. Yeah, maybe we should refresh ourselves on OSI. You have studied OSI. You must have covered a networking module where you have studied the layers of OSI. We need to refresh with respect to the OSI, because any networking follow normally basically OSI. Even TCP, you see on the right hand side here, you have the TCP IP protocol stack, application layer, transport, internet layer, link layer. OSI traditionally below is a physical layer. So if we can do some refresh on the OSI, because since we are discussing our protocols, it will be protocols for the different layers. So we do a refresh on the OSI layers. I will ask you, the class, you can guide me through the OSI layers. You have studied it a very, that is, I think last year you should have studied OSI layers. I have studied it something like 20 years back, so you should know it better than me. At the physical layer, what do we have? What kind of protocols do we have? Or what do we do at the physical layer? Anyone? Physical layer?
Captures the data in terms of signals.
Okay, yes, signaling. You have mentioned the word signaling. Generation of the signal and generating appropriate signal that can be transmitted on the medium, depending which medium we are using. We are using coaxial cable, it is wireless, the frequency at which we should emit the signal, everything about the signaling, raw signal and the medium. This is physical layer, right? You're right. Let's move on up. Data link layer. What is the main purpose of the data link layer? Another student from the class?
Defines the format of the data.
Format of the data, yes. There is a format very often we use at the data link layer. What is this format? Anyone? in normal network that you have studied, the format of the data, there was a name we have used for it. Which name? Well, because when we talk about data link, this is the thing that should come to your mind. Which thing? Which format? Your friend is right by saying that the data format, right? I agree with this. But which format? There's a name that we use there. Anyone in the class? No, you apply computing student. This should be something very easy for you. Which format are we talking here? It is data link layer, yes. The information is put into something. How do we call this something? The information to be transmitted is put in an envelope. What is the name of this envelope for transmission?
Frames.
Say it again.
Frames.
Frames, exactly. The name that we use is frame, data frames. Excuse me. So in networking, we talk about data frames. That is, at the data link layer, we form data frames with a header, a footer. In between, you have the different, you have the payload, and then the different control. We call it PDUs, protocol data units. So this is frames, data frames. Okay. When we talk about data link, what comes to my mind is data frame. We put the information in an envelope that we call frames. Okay, let's move up. Network. When we talk about network layer, what comes to your mind? What do we do at the network layer?
Packet routing.
Okay, yes, routing comes to my mind. Path determination come to my mind. Packet come to my mind. Yes, we need to have our information in terms of packet, and in the packet, one very important information is in terms of the addressing, the destination address, sender and receiver, sender address and receiver address. This is what comes to my mind when we talk about network. And obviously, tomorrow, if you are discussing a routing protocol is found at the network layer, because routing protocol determine the path that we should take in the network in order from that sender to go to the receiver. So net routing, this is called routing, and routing is a network layer operation. Okay, this is how you should recall your OSI. OSI is in an ABCD for networking. Knowing your OSI is very, very important. Then you will be able to situate, okay, when we're discussing a protocol, it falls under this layer, this is its purpose. Let's move one step up. I see transport layer. Anyone give me some indication of transport layer? Any information you can give me about transport layer? Functionality of transport layer?
It is responsible for transmitting the data using the transmission protocols.
Okay, so we are talking about something about transmission protocol. We are talking about establishing a link between the sender and the receiver, okay, and maintaining this link. When we talk about transport, a protocol is this kind of link that we are establishing between the transmitter and the receiver. This is the transport protocol. Let's move slightly up. Session layer. Anyone? Oops. Session layer. Closely related to transport, but session layer. What do we do at this layer? Anyone in the class?
Managing the communication between different computers.
You're right.
Yeah,
Yeah, definitely. This is what we do at the session layer. It's more about managing the link that has been established between the sender and the receiver. Or if we can put it this way. There are other operations that I have not discussed, like error checking, retransmission, packet loss, and everything that comes down. But anyway, let's not go into those details. Let's move slightly up. Presentation layer. What is the purpose of the presentation layer? Anyone?
ensures that data is in a usable format.
Okay, data can be read. Data is is in a format that will be understandable by the application. For example, this is the presentation layer. It's more about the data formatting. Okay, for transmission and for reading as well. If we go one step more, the last layer, the application layer, or the first layer, if we take it from the top, application layer. Anyone?
This is the layer that uses the data from the presentation layer and then present it to the end user using some protocols.
Exactly, you're right. Exactly. For example, if you are using a browser, for example, the browser its task is to take the information and display it on your browser so as you can read it or whatever. If you are using an email application, your browser, an FTP application, and I think this is what it will do: present the data to you in an format that is that you can read. Okay, so we have gone through the device, and I advise you to keep this in mind always, because this is an ABCD of any. Since we are discussing we are discussing protocols, I wanted to map all the protocols that we are going to discuss, to map it to the OSI layers, and you can see mapping has already been done here in the middle. We have seen the left hand side, we have seen the right hand side. Now let's see the middle. We are more concerned with the middle part here, which is called the IoT protocol stack. Let's start from the below, completely down. Okay, at the lower layer, physical or MAC layer, it is combining the data link. In our case, I've already mentioned to you, we use more of IEEE 800.15.4. Okay, IEEE 800.15.4. At the physical layer, most IoT sensor system, this is what you use. In the first semester, I think I've discussed it lengthily with you. Now we are starting to have even Wi-Fi for IoT system. Okay, .ah, 11ah. Okay, this is why you see 800.11 as well. If we go slightly up, we have discussed in first semester in access technologies, there was a discussion about 6-low wireless span. Anyone in the class can give me any indication what is this 6-low wireless span, what we use it for, what was its main purpose? A discussion we had in first semester. 6-low wireless span.
It makes IEEE 802.15 IP enabled.
Okay, very good. In very simple terms, your friend have explained it. That is, we have said 800.15.4 is not IP enabled. We cannot transmit IP packet there. But this is the packet we use in our sensor system. Now, if you want to transmit your data to the internet, from internet to your network, or from your network to the internet, definitely you need to convert whatever information in terms of IP packet. And this protocol, this is what it does basically. Anyway, 800.15.4, the format of the packet is much smaller, okay, whereas an IP packet is much larger, longer. So this 6-low wireless PAN protocol, it do this mapping. There is an adaptation layer there, okay, that do the adaptation from the different packet format, IP packet and 800.15.4 a packet. Yes, basically in simple terms, make your IoT system become IP enabled. If we go slightly up, transport layer. At transport layer, for normal transport layer over the internet, we use TCP. Okay, this is why it's called TCP IP. TCP we use it at a transport layer, and there is another protocol that is not so much used when we talk about TCP IP is UDP, but it is available even over internet. We can use a UDP, and you will see UDP is more relevant for IoT as we proceed with our discussion, because in IoT we don't use so much TCP. Instead, we use more of UDP. And why? This is a question we are going to address as we proceed in this lecture. Slightly up, this layer is very important when it comes to sensor systems, to IoT system, is is once again, yes, at this layer, the application protocol layer, because we have transmission of data, small packet of data, small amount of data to be sent very frequently. There is something called messaging protocol that we use in IoT system, in sensor system, and those messaging protocol, they are unique to IoT. Okay, this is why at this level you see HTTP, we don't use it that much. CoAP, yes, a lot. XMPP, AMQP, MQTT. So these are the protocols that we are going to discuss and that are heavily used in IoT system. For sure, I have 1 week only on CoAP. I have 1 week only on MQTT. I have 1 week only on AMQP. So you will see we are going to discuss those protocols in very much detail, and you will be examining on those protocols how they work, how they do transmission. All these things will be discussed in very much detail. Okay, so let's proceed higher up. Service. We won't be discussing much about this. Is at the higher level layers when you will be implementing your application, depending on how you want to display your information and everything. But one of the most important layer we are going to discuss in this chapter is this one here, application protocol layer, where we have CoAP, AMQP, and MQTT. MQTT is one of the most used protocol when it comes to IoT system. Okay, let's proceed. This is more or less the same thing, showing to you the difference between on the web, for example, on the right hand side here. Okay, we use TCP/IP, HTML at the data format HTTP at the application layer, TCP, UDP at the transport layer. At the internet layer for the routing, I think it is IPv6, IPv4, and everything. And below, either if you are using wired network, it is IEEE 802.3. If it is wireless, it is IEEE 802.11 Wi-Fi. Okay. Whereas IoT, we have just done this. At the lower level layer after you, it is 802.15.4 most of the time. At the network layer, everything is 6 low wireless span. At the transport layer after you, we don't use TCP. Instead, we use UDP more. Okay, and then at the application here, and this is what we are going to study in this whole chapter: CoAP, MQTT, XAMQP. So all these things are used at this layer, and in terms of data format, it's more JSON or binary format that we use. So this is again showing to you other different layers, the type of protocols that is relevant for IoT. This is called IoT protocol stack. Okay, yes, after you, especially this is more relevant for this layer here, the application layer, CoAP, MQTT, and everything. These are very often called messaging protocol, where we have the actual data being transmitted. You see, you have different strategies for transmission of the data, and we don't have one strategy in IoT that we use, one fixed strategy that we use. It depends on your application. Then you decide which strategy, which messaging protocol you are going to use. If it is HTTP, normal HTTP, you make a request, you get a response. And HTTP, when over the internet, this is what we use. You type HTTP www.um.ac.mu. This is a request you are making to the UOM server. Then you make a request, you get a page. This is HTTP, request response. We call it, it is synchronous request response. You need to connect to the server responds to you with some information. This is called synchronous. If, for example, the UOM server is down, will you get access to the UOM website? Obviously not, because you're not able to connect to the server. This is what is called synchronous here. Synchronous request response, and HTTP works this way. But however, we can have also asynchronous. Asynchronous means it's not necessary that both parties they are connected to each other for for data to be transmitted. What happened? The client sent a request. Then the server will respond in its own time. We acknowledge the request and then will respond in its own time. This is called asynchronous request response, and CoAP normally uses this strategy. Now there's stream request response. Stream means you need to have a connection established between the server and the client, and this is reserved. This is why it's called stream. This connection is reserved for the duration of the exchange of data. It's not that it can be stopped or whatever. It needs to be reserved. You have all your message exchange in between, and then at the end you disconnect. You destroy the connection. This is called stream request response. And then the fourth one you see down here, which is we call it very often subscriber publisher or subscription notification strategy. Many protocol you see here, MQTT, AMQP, even CoAP works both ways, asynchronous request response, or it can work subscription publisher as well. This one works slightly different. I will just give you an idea, but we will discuss it in detail when we discuss about CoAP, for example, or MQTT. In this one, what happened? You have a subscriber, or you have a sensor, for example. The sensor can act as a publisher that capture data and send it to a broker. The broker just capture this information and store it. And the subscriber is an application that want to have access to a sensor data. It subscribes to that data to the broker. So basically, there is no direct connection from the client to the server. Instead, in between, there is a broker that collect data from the server and collect requests from the client and match those two. Do we have data for this request? Yes, it transmits the data to the client if we have data. If we don't have data, it will tell the client, no, we don't have this data that you're requesting. So in between, we have something called a broker. Don't worry about it if you have not understood this one. We are going to discuss in very much detail in our future chapters. Okay, yes, after you one type of protocols, and very often it is linked more to this layer, application layer here, CoAP, MQTT. So these are called very often messaging protocols. So IoT messaging protocol, also known as instant messaging, many used for chat communication on the internet. Over the internet, we are using this protocol for chat. Now we have it for our IoT systems. So MQTT, CoAP, and everything I've just mentioned these to you. Okay, are mainly designed for IoT application. So the properties of this protocol are message management. So it says how to capture the message, how to store the message, when to transmit the message. All those things are governed by those protocol. Today we have two broadly adopted protocols to cope with IoT static connectivity. So we have two main ones that we use, and both we have one complete session on MQTT. We have one complete session on a CoAP. MQTT stands for Message Queuing Telemetry Transport, and CoAP stands for Constraint Application Protocol. So you need to know how those protocol works carefully, because I can already tell you in your exam paper, definitely you will have one question related to one of those protocols where you have to explain how it is working, how data transmission is happening and everything. So this is why you need to know how those protocols work very carefully. Okay, so this is messaging protocol, application layer protocol. At the data level, we have discussed last semester when we were discussing mainly with chapter access technologies. Yeah, at the lower level, we use IEEE 100.15.4 mainly, but otherwise you have like BLE, Z-Wave, ZigBee, all these things have been discussed last semester. Okay. Is mostly commonly used for IoT standards, so IEEE 100.15.4. I've been telling you this is the protocol of choice when it comes to sensor systems, to IoT system. This is the protocol we use. We don't use IEEE 800.11, that is Wi-Fi. Okay, we don't use IEEE 800.3. This is mainly wired. Okay, and we use 800.15.4. Well, anyone in the class, we have discussed a lot about this in first semester. Why IEEE 800.15.4 that we use in IoT and sensor system at the lower layer? What makes it interesting and appropriate for IoT system? Why do we use 800.15.4? Why, for example, we are not using, because Wi-Fi is already well established, we have it everywhere. Why we have not gone for Wi-Fi, IEEE 802.11? Anyone in the class? It's very obvious, again.
Because of its power saving capability.
Yeah, exactly. It's a matter of energy, it's a matter of power. Okay. IEEE 802.11 Wi-Fi still uses a lot of power. That is not suitable for sensor system. Sensor, you need to use a lot less power. And IEEE 802.15, these are called, very often they are short range and they are low power protocol. They are low power, consume very less energy. This is one of the main reason. Okay, so it defines frame format. Yes, when we talk about IEEE 802.15.4, because you recall at the OSI layer, these two layers, is physical and MAC layer. Data link is already combined here. And what I have told you about data link, MAC frames, the format of the frame that you will be transmitting. So this is why it is saying here, at this layer, it defines a frame format, headers, including source, destination, address, how nodes can communicate with each other. All these things are already taken by this IEEE 802.15.4. The frame format used in traditional are not suitable. This is a question I've just asked, why they are not suitable for low-powered multi-hop networking, because of the power due to their overhead, because they consume lots of energy. This is why they are not appropriate for IoT. This is why we use 802.15.4. So in 2008, IEEE 802.15.4 that is .4e was created and extended 15.4 and support low power communication. It's really low power communication. This is at the data link layer. Here I'm just browsing at the different layers again here, telling you a few protocols that are relevant for IoT. We have seen at the application layer, we are seeing at the physical and data link layer. At the network layer, I've already mentioned to you one of the protocols that are most relevant, 6 low wireless span. So one problem with IoT application is that IPv6 addresses are too long. We cannot use IPv6, before even IPv6 in IoT data link frames, okay, which are relatively much smaller. I've already explained this to you, okay. However, we still want to transmit data from our network, sensor networks, to internet, normal internet. This is why there needs to be a, how do we call it, a transition, a conversion of one format, 800.15.4, to another format that can be transmitted over the internet, that is TCP, TCP/IP, that is IPv6, for example. So IETF is developing a set of standards to encapsulate IPv6 datagram in different data link layer frames for use in IoT application. And one of the main protocols that they have come up with is 6 low wireless span that we have discussed last semester. Last semester, we had long discussion about this one, how was an encapsulation and adaptation layer, how we were able to transmit IEEE 802.15.4 packet, the frames, to IPv6 using these 6 low wireless span. This is at the network layer, if we can put it this way. This is what happened. You can, again, I think more or less, again, we are explaining it here. The same thing that I've just told you. So it is a secret source that allows larger IPv6 packet to flow over 800.15 links. This is the main thing I've been telling you here. Support much smaller packet size. It is a matter of packet size. One use small packet, that is 800.15.4 in IoT is a small packet, whereas IPv6 is a large packet. So how to do this this conversion? This is done by 6 low wireless span. So it is acronym for IPv6 over low power wireless personal area network. Okay. So without 6 low wireless span IPv6, we would not be able to communicate those packets over TCP/IP, and you can see clearly here in the diagram below. Below it is purely IoT, that is IEEE to the 15.4. There is a mapping which is done here, 6 low wireless span, and above it is the TCP/IP, that is IPv6. At the transport layer, recall after you, over the internet, we mainly use TCP, but in IoT system, in sensor system, we don't use TCP. Why? The answer should be on this slide. Let me check it. So while TCP is used predominantly in the internet, over the internet, as transport layer protocol, except in gaming and video streaming where we use UDP. Okay, most IoT scenarios are well suited for UDP and not TCP. UDP is a much lighter protocol. Already we get the answer here. Why we don't use TCP? TCP is heavyweight. TCP consume more, whereas UDP consume less. So obviously we go for UDP instead of TCP when it comes to transport. Recall transport layer we have seen where we do this link between sender and receiver. So UDP is a connection protocol as does not come with resilient features of TCP. TCP where we have guaranteed packet delivery. Okay, when a packet has not been delivered, you have acknowledgement, you can retransmit and everything. You have error checking and everything. All those things are not there. Yeah, anything? Anyone have requested something? Can you hear me? Can you hear me? Anyone?
Yes, I was just testing my microphone. Sorry.
Okay, that's okay. So I'm just want to make sure that you can hear me. Yes. On what is the issue here is TCP is doing error checking. It guarantee packet and thing for all those operations. It become very greedy in terms of resources, whereas UDP don't do those things. This is why it is lightweight and suitable, making it suitable for constrained environment of devices and sensors. This is why. So if you maybe ask a question, why UDP is more appropriate compared to TCP for IoT application? Already it is a question, an exam question. Why UDP is more appropriate for sensor systems as compared to TCP at the transport layer? So you should be able to explain this. At TCP, we do error checking, guaranteed packet acknowledgement, and everything. And all these makes TCP heavy. Okay, whereas in IoT we are working in a constrained environment. Okay, and UDP is faster and lightweight, and this is why we go for UDP. So it is very clear why do we use UDP in IoT system. Okay, so and then there is here what is called DTLS. Okay, datagram transport layer security. This is to add security to our a transmission. This is the security aspect of the transport layer protocol that we use in IoT application. Okay, let's continue. This is at the transport layer. So main point for the transport layer, recall, we use UDP instead of TCP, and why it is so. You need to recall this. Let's continue. The session layer, again, application session. It says here session/application. We are combining both here. We have all those protocols. We are going to discuss those protocols in very much detail, MQTT, CoAP, and everything. So most IP applications, including IoT, use TCP or UDP. However, there are several message distribution functions. Okay, like how do you queue your message, when you transmit, when you save, all those things, they are decided at this layer, at the session layer, application layer, and these protocols normally will guide us. MQTT, just quickly, we have complete chapter on each of those protocols. I won't dwell much on it here. So it is a publish-subscribe architecture. Publish-subscribe after you have a broker, sensor sent to the broker, client requests information from the broker. If information have been received, the broker will transmit to the client. Otherwise, we'll say that we have no information for you. So MQTT was introduced by IBM. Okay. From IoT point of view, publishers are basically lightweight sensors. This is what I would say. Publishers, they are sensors that connect to the broker, send their data, and go back to sleep whenever possible. That is, sensors don't have to remain active. And then subscribers are application. Your whatever application you're using, your mobile application or whatever that read data from a sensor, this will act as a client, will connect to the broker to receive the data. Don't worry, this will have lengthy discussion that will come. And anyway, you see a diagram here. I have included a diagram here. These are the publishers, sensors, transmitting data to a broker. And here the data, it is queued for subscriber, those who want to have access to those data. The broker will transmit it to the subscriber that have shown interest in a particular data. So subscribers need to, this is why they are called subscribers. They subscribe to a specific data. And if the broker receives data for that particular topic, it will transmit it to the subscriber. Okay, so you see here a summary again here of the different protocols. We have just done an introduction today here of IoT protocol for sensor systems. And as from next week, we are starting to take one by one each protocol and discuss it in detail. For today, I wanted just to introduce to you the different layers, and at each layer the type of protocol that we have. Recall your OSI layers very well, what we do at each layer, because each of the protocol that I'm going to discuss with you, it will relate to a specific layer. This is it. These are a few links. You can check it out on IoT protocols. Yeah, I think I've reached the end. Any question from anyone on this set of slides that we have just discussed? It was only an introduction to IoT protocols. We have detailed discussion on each of those protocols that I've introduced today as from next week. Yeah, any question? You will have to understand very well publish, subscribe. I've just browsed through it today, but when we discuss, for example, CoAP, which is publish, subscribe, I will explain it in very much detail. Don't worry about it. So we have I've covered in this first set of slides. I introduced the whole IoT protocol stack. Okay, starting from the lower level of physical data link, network level 6 low wireless PAN, then upper level transport UDP mainly, then higher we have CoAP, MQTT. This is what I wanted to communicate to you today, just for you to have an idea. So as from next week, when I discuss it in detail, you can situate what are we discussing, where it is in the protocol stack. But recall the protocol stack very well. Yes, no question from your side? Okay, if you have no questions for this lecture, our first part, I have already posted it on Google Classroom, and this set of slides. One of you have requested for the video lecture for loss access technologies. I will check it out just after this this lecture. I will try to post it. On Thursday, we won't have that is online lab, but I'm already giving you your task for the lab for this week. Okay, you can do it in your own time. That is for the chosen topic. Okay, I still need to locate where it is. The file. I recall there was a file that was shared. Is it on Google Classroom?
Yes.
If it is there, we can just quickly have a look. Don't see it in my list here.
It was right upstairs. The name is mini project. The fourth
Can
one.
you see it? Okay,
Yeah,
okay, yeah, it is here. It is here. Okay, thank you. We can quickly have a look. My still is still shared here. You can view. You can see it.
Yes.
Okay, so you see here the purpose: 3 or 4 students working on a prototype implementation of a sensor system. Now it is prototype implementation or design. It depends on how things will evolve. We keep it implementation for the time being. Hopefully, you will get access to the labs where you can mount your prototype. But there are lots of work that needs to be done prior. So this is what I want you to start doing from this week itself. So I see Subrati, Rose, Proshan, sign language translation glove, Ramjani Chaman, Badabakas, Basu, smart agriculture system. So, example, smart agriculture system, it's a big theme. Now, what you're going to do inside it, this is now you need to reflect and work out the requirement. I see next Vikesh Keshav and Sue Farley, a smart home system. It can be, I don't know, controlling of lights or whatever. It depends on what you have in your mind. Edu, Ramjas, Sibarat, Mohabir, I see fire and smoke detection. It's okay. I'm just validating all the different theme. For Aho and Edu, Amal, Budan, I see smart robotic car. Here, obviously, you need those equipment, okay, necessary equipment. Otherwise, you work out the design. Bandu, Badal, Jadu, I see automatic room light systems. Bagalu, Lal Mohamed, Babua, Rojua, I see intelligent alarm system. Jason, Henri, Sigulam, Gosai, I see smart cars and shield. Widad, Lawa, Jawahir, Yodish, Niranjan, I see gas leakage and alert system. Shaheen, Chatu, Edu, Sibchan, I see pet feeder system. Okay, I hope all of you have already put your name. So if we say 10 by 4, yeah, it should be more or less all of you have already put your name in there. Okay, so you work accordingly. All the titles you are given, they are valid. Okay, now within it, what you intend to do, this is you will have to formalize it. This is the first task. That is what I call, let's call it requirements analysis, performing requirements analysis of your system. That is, you identify the functionalities of your system and everything, and put it in a document, because I think I have said, let me check in the guidelines. Student will be required to submit a report describing the overall system, the setup, technologies, functions, implemented codes, and functions, implemented codes, extract, and everything. We will have to demonstrate the system in the lab. This is depending on opening. Yes, so otherwise we can even have, if it is only design, we won't have demonstration. But if we have been able to do the prototype mentioned, then definitely there will be demonstration in the lab. What I will do also from my side, I will publish the list of equipment. I have a copy. I will publish the list of equipment that we have in the robotics lab. If you want to bring changes to your topic, you will still be allowed to do so based on the equipment that I will be publishing. Okay, no issues about it. But don't keep on changing your titles. I won't allow this. I don't know whether this is still editable for you. If it is not, you inform me. I think it is still editable. You can edit this document. Otherwise, yes, two things I need to post here: a previous lecture on access technologies and list of equipment that we have in the robotics lab. I can give you access to some of those. Obviously, if two free groups are requesting the same equipment, we will have to share it. And normally there is a logbook and everything that the technician in the robotics lab is managing. So we will have to record who is taking which equipment and everything. Okay, and carefully. And ideally, if university is open, I would prefer that you use your lab time, you work there only. Okay, you already have your design very careful and thing. There you mount your prototype and you do necessary coding and everything. So we will discuss it accordingly. For the time being, I will publish the list of equipment, so as you have an idea, you can include it, even smart agriculture, even other systems, smart home. You can see what we already have. A smart robotic car, you can see what we already, intelligent alarm system and everything. You can see what we already have, and accordingly you may include it in your prototype. Okay, any question?
There's
So
actually
check.
I'm
Yeah,
sorry, there's actually some students that are not being able to record their team name and the title there. They have tried it several times, even during the vacation time, but it was not allocated there.
why? Because most of you have been able.
Yeah, maybe it's because of the timing. When the time they were entering that, it was no more editable, but they did send you a private chat on Google Classroom.
Okay, what we'll do from my side, I will check if I can open the document again, extend the and make it editable.
Yes.
We'll request them to. So if we have any such student in the classroom here, do check the document again. Okay, I will try to see if there are some timeline was associated with it and whether it was editable. I will check it again and make it out because I've said even others you can do modification to your title based on the equipment that I'll be publishing. So I will try to make it editable by everyone. Okay. Yeah. Any other question? Okay, if not, so for this week, so even the lab I'm planning, I'm giving you your task. Okay, for this week, each group at least have one meeting, one obviously online. Can you hear me?
Yes.
Yes.
Now.
Okay, I think there was some network issue. So anyway, I'm closing right now. No issues. Check out Google Classroom for previous lecture, for list of equipment, and edit your mini project as well. And for this week for the lab, it is mainly requirements requirement analysis. Work on it. Next week in the lecture, I will give you other instruction for the mini project. Okay. So let's end the lecture here. I'll see you next week again, same time. Bye bye.